Welcome back to Geometry, Measurement, and Probability. In this video, we'll be looking at section 13.4 where we discuss surface areas. So let's get started. Let's start by thinking about a cereal box. A cereal box is composed of a series of rectangular regions. And the surface area of the box is the sum of the areas of all of these regions. To find the surface area of a right prism, like a cereal box, we find the sum of the areas of the rectangles that make up the lateral faces, those are the faces around the sides, and then the areas of the top and the bottom, that would be the areas of our bases. The sum of the areas of the lateral faces of the prisms is what we call the lateral surface area, or the LSA. And the surface area of the prism is the lateral surface area plus the area of the bases. So let's think about that cereal box, and we want to find the surface area of our cereal box. First, I notice the front and the back of the box are the same. So I have two rectangles. I've marked them with a purple X. And to find the area of a rectangle, I multiply the length times the width. So the length here is 8 and the width is 11. Plus, think about the top and the bottom of the cereal box. They are the same, so there are two of them. I've marked them with blue X's. The length and width of the top and the bottom of the cereal box are 2.5 and 8. Then last, I have the two sides of the cereal box that I marked with a black X. The length and width of these sides are 2.5 and 11. Use your calculator and multiply here. 2 times 8 times 11 is 176. 2 times 2.5 times 8 is 40. And 2 times 2.5 times 11 is 55. And when you add these together, you get 271. Now I need to think about my units. In each case for my rectangle, I was multiplying inches times inches. So my units here would be square inches. Anytime we have area or surface area, our units will always be square. Now look at example 1. Let's find the area of our box. And then we want to know, could the box be made from a rectangular piece of cardboard that is 21 inches by 15 inches? And if not, what size rectangle is needed? So first, let's start by thinking about our surface area. So for our surface area, I think about the front and the back of the box. I've marked them in purple. These are rectangles. There are two of them. They have a length of 4 and a width of 4. Now, think about the top and the bottom of the box. I've marked the top and the bottom in blue. There is a top and a bottom, so there are two of them. And the length and the width are 4. Then last, let's think about the sides of the box. There are two sides to the box, and each side has a length of 4 and a width of 4. 2 times 4 times 4 is 32. And when I add that together, that gives me 96. Again, I need to think about my units. Now notice in my picture, my units are centimeters. So when I'm finding the area of each side of the box, I have centimeters times centimeters. That means that my units are square centimeters. This is the first thing that the problem asks us to find. Next, the problem asks us, could the box be made from a rectangular piece of cardboard that is 21 inches by 15 inches? So I need to find the area of the piece of cardboard. The cardboard is a rectangle that measures 21 by 15, so length times width, 21 inches by 15 inches. And that gives us 315 square inches. Notice that my units are different. My surface area is in square centimeters, and the cardboard area is measured in square inches. So I need to have the same units to be able to compare. I'm going to take the 96 square centimeters and change it to inches. Now 1 inch is about 2.54 centimeters. Notice the centimeters has a power of 1 in the denominator, but we started with a power of 2 centimeters squared. So I need to repeat that unit ratio. And now my square centimeters cancel out. Type this into a calculator. Type in 96 divided by 2.54 divided by 2.54, and that gives us 14.88 square inches. So yes, we can make the box from a rectangular piece of cardboard that is 21 inches by 15 inches. Now look at this triangular prism. So I need to think about finding the area of each side of the prism. I'm going to start with finding the area of the bases. The bases are triangles and there are 2 of them. I've highlighted them in purple. The formula for the area of a triangle is 1/2 base times height. Now remember, in a triangle, the base and the height are perpendicular to each other. So here the base is 3 and the height is 4. Then I think about my lateral faces. So let's start with the back right. I drew around the back right in blue. This is a rectangle. The length is 4 and the width is 10. So 4 times 10 to find the area of that rectangle. Plus, let's move to the back left. I've drawn around the back left in black. The length is 3 and then the height is still 10. So we have 3 times 10 to find the area of that rectangle. And last, we need to find the area of the front. You'll notice I drew around that one in green. The front has a length of 5 and a width of 10. Then multiply and add. The 2's cancel out in the first term, and 3 times 4 is 12. 4 times 10 is 40. 3 times 10 is 30. And 5 times 10 is 50. When you add all of these together, we get 132. And again, I need to think about my units. My units here are centimeters. And so when I multiply to find the area, I have centimeters times centimeters gives us square centimeters. Look at the next part of example 2. We have another prism. This one is a rectangular prism. And so when I think about my surface area, I think about finding the area of each of the faces. Let's start with the bases, the top and the bottom of the prism. Now the top and the bottom, I've drawn around in purple. These are rectangles, so to find our area, we multiply length times width. There are 2 bases, so 2 times 4 times 6. Now, let's think about the sides, the left and the right side. I've drawn around these in blue. These are also rectangles, and there are 2 of them. We multiply the length of 6 times the width of 10. And then last, I need to get the front and the back of the box. I'll draw around these in black. There are 2 faces here. They each have a width of 4 and a length of 10. 2 times 4 times 6 is 48. 2 times 6 times 10 is 120. And 2 times 4 times 10 is 80. When you add these together, you get 248. I need to include my units. So here, centimeters times centimeters gives me square centimeters. Now, let's think about the surface area of a right circular cylinder. I can think about taking that cylinder and cutting down the side of the cylinder and opening it up. Notice here that I have a rectangle and I have 2 circles. The formula for the area of a rectangle is length times width. The length here is 2 pi r and the width is h. Now the formula for the area of a circle is pi r squared. So here's the formula for the surface area of a right circular cylinder. In example 3, we're asked to find the surface area of our figure. This is a cylinder, so I use my new formula, 2 pi rh plus pi r squared. Then fill in for r and for h. The radius is 2 and the height of the cylinder is 3. Even though the cylinder is laying on its side, that height is still 3. 2 times 2 times 3 gives us 12 pi. 2 squared is 4 times 2 would be 8 pi. These are like terms, so add them together. It gives us 20 pi. And type this into your calculator or read your directions in MathLabs. If MathLabs asks you to leave the pi, then don't type it into your calculator. 20 times pi, or 20 times 3.14, is approximately 62.83. Notice I use the squiggly lines for approximately because we rounded here. Last, think about your units. Again, I have centimeters times centimeters, or at the very end of my formula, I have centimeters squared. And so my units here are square centimeters. Now look at example 4. An aluminum juice can has a height of 5 inches and a radius of 3 inches. We want to know how much aluminum is needed to make the can. So we're thinking about our surface area of our can. So the formula for our surface area is 2 pi RH plus 2 pi r squared. Fill in your radius and fill in your height. Now this time you'll notice that I included the inches in my formula. You can include the inches in your formula, or you can think about your units at the end of your problem. Plus, again, the radius is 3 inches. 2 times 3 times 5 is 30, so we have 30 pi and square inches. 3 squared is 9 times 2 would be 18 pi square inches. Add these together, it gives us 48 pi square inches. Again, read your directions in math labs. They may ask you to leave the pi in your answer, or they may ask you to multiply it out. 48 times pi, or 48 times 3.14, is approximately 150.796. And don't forget your units here are square inches. Join me in our next video as we look at the surface area of a right regular pyramid.